Today we're going to take a look at some of the properties that are going to become important in this unit. So I'd like you to turn to page 12 in your packet, and we're going to take a look at put an application of geometry to things that we already know from algebra. So we have a bunch of key terms here which would be helpful in terms of you making note cards and things like that, but we're going to focus our energies down here. Properties of real numbers in geometry. So the first one that we're going to highlight is the addition property of equality. Now we've used the addition property of equality in algebra, but this one, and this is actually the definition of a property that we use in algebra. So if A, B, and C are real numbers, and we know that A and B are equal, then A plus C equals B plus C. So if we think about that in terms of, say, Bob and Jeff have the same amount of money. Well, so if A is Bob and B is Jeff, and they have the same amount of money, and I would say gave Bob another $3, I have to give Jeff another $3, and then the total that they have would still be equal. So we're going to think about, so basically this is adding the same value to both sides of the equal sign, and it's still being equal. So a lot of times with what I do is I put clouds around it so that you can see it's adding to both the same side. So let's look at how that applies to angle measures. So if we know that the measure of angle 1 equals the measure of angle 2, then I can add this angle 3 to both sides, and it's still going to be equal. So let's kind of draw a little picture here. If I know that I have, say, an angle, say this is angle 1, and over here this is angle 2. So basically what that's saying is if angle 1 is the same measurement as angle 2, and I were to add this angle 3 to angle 1, then it would have to be equal to angle 2 plus angle 3. So you can write a statement. It asks you to write a statement that applies to angles. So let's put some letters in here. We've got A, B, C, D, E. So we would say that if, so we have a conditional, if the measure of angle ABC equals the measure of angle EBD, then I can add the measure of CBD to both of them. So then I know the measure of angle ABC plus the measure of angle CBD. Should have done that one in red though, so that you could tell what I was doing. So I'm going to put a cloud around it so you can see that that's the thing I'm adding to both sides. This is the measure of angle EBD plus the measure of angle CBD. Put a cloud around. So I'm adding that same thing to both sides. So your job is going to be to write a statement using segments. So maybe you have a segment AB, and you have a segment CD, and you know that those two are the same. And maybe you're adding BC to both sides. So I'm going to have you finish up that number 2. And now let's go ahead and flip over here to subtraction. Subtraction property of equality just says that if I have A, B, and C, and they're real numbers, and I know that A equals B, then I can subtract off the same amount. So again, it's asking you to give an example of that in terms of angles, and then one in terms of segments. So if we had, say, we could kind of use that same picture with our angles. I'm going to draw it for you, and then I want you to finish it. Let's let that be E. So let's say this is angle 1, and this is angle 2. Then maybe I know that, I'll go ahead and write this one, then I want you to mimic it for the segments. If I know the measure of angle BCD equals the measure of angle ACD, so let's color them. I know that is equal, to this. If I know that's true, well, the thing that they have in common would be that angle 3. So I could subtract that off of both sides. And it's not going to change a thing. It's still going to be equal. I can subtract that amount from both sides. So that would be our subtraction property of equality. Reflexive properties, right now it doesn't make a whole lot of sense. I kind of call it the duh property because it's a number equals itself. A measure of angle 1 equals a measure of angle 1. AB is congruent to AB. So you just need to make a statement for angles and segments. Substitution just says I can sub something in. Now we did this a lot in Algebra 1. If I said f of x equals 2x plus 1, and I ask you to find f of 3, it's subbing that 3 into x. So I have 2 times 3 plus 1. And that would be substituting it in. If you look here at the examples I gave you, angle measures, the measure of angle 1 is 56, and the measure of angle 2 is 56. Well, then I could go ahead and sub in measure of angle 2 in to 56, and I know the measures of the angles are equal. So that's substitution property. So I would read through those. These are definitely all cards that you're going to want to make. And we're getting about there. You're going to need to do a substitution one for angles and segments. You need to finish that up. Transitive is, I think of it as relatives. So we're going to do a side example over here. If we have, let's say, Evan is related to Sammy, and Sammy is related to Grace, then what can we conclude? Well, we talked about it yesterday. The middleman was Sammy, so if we're not eliminating Sammy, but if we know Evan is related to Sammy, Sammy is related to Grace, so therefore we know Evan is related to Grace. There's got to be that middleman right there. And so that's what's happening here, and that's called the transitive property. If A equals B and B equals C, the B's need to be right next to one another. Then we know A equals C. So you're going to write one for angles and write one for congruent segments. So you're going to have something is congruent to something and something is congruent to something else, and then you're going to put them together. So you might look at those examples. You want to write your own. So that's really what we've got. That's pages 12, 13, and 14. I would like for you to flip to page, this will help you on the bottom of, or the top of 26. We have name the property. And so we have a couple things here that you're going to basically name. You're going to talk about your properties off to the side, and then I would like you to do number 2. I want you to write out on page 28, number 2, number 3, and number 4. I want you to give me detailed steps on how you would solve that. Give me every detail, because we're going to tell what properties we would assign to each of those steps. You need to make sure that you do that. I think we're pretty much set up, with the exception of symmetric. We forgot to do symmetric property here. Let's throw that one in. Symmetric property just says if A equals B, then B equals A. So basically we're just switching sides of the equal sign. That would be symmetric property. I think that takes care of it. We've set up our properties. You will want to put those on note cards. We've got a lot of them this time.